assignment and graph most of the graphs just on the assignment itself instead of doing it on paper. So the current objective is graph cotangent functions. It says on the graph of f of x equal cotangent x and the interval negative pi to pi, so this is our domain. For what values of x does f of x equal 1? Choose the points in the figure. So our domain is from negative pi to pi. So negative pi all the way to pi. And they want to know when the function is equal to 1. Well, the function is equal to 1 at this y. If I could draw a line across this y equals 1, a horizontal line at y equals 1, you can see it touches this cotangent function in two different spots. So I need to drag this dot up to the 1 piece and drag this dot to that 1 piece as well. And then hit submit. And those would be my two spots where the function equaled 1. Now it says graph cotangent functions. Graph tangent functions. It says choose one point in the figure that is not in the domain of f of x. This is 1/5 tan x. And you have negative 2 pi to 2 pi as your domain, or your interval. So negative 2 pi to 2 pi is here. And they want us to look at 1/5 tan x. And they want to know where's the figure not in the domain. So we want to look for those asymptotes. So if we just put this dot on any asymptote, we would find a value that this function is not defined at. So we have this asymptote here at negative pi over 2. We could choose pi over 2 as the asymptote, or 3 pi over 2, or negative 3 pi over 2. Any of those would work, because those are not part of the domain. Here we're back to graphing cotangent functions for the objective. It says on the graph of f of x equal negative 1/4 cotangent x and the interval negative pi to pi, for what value of x does the graph cross the x-axis? So it wants to know where the zeros are for the graph. Well, that would be at pi over 2 and negative pi over 2, and both of those are within our domain value, which was negative pi to pi. So once you set those on the zeros of the function, we can go ahead and hit submit. We're back to the objective graph tangent functions. And it says on the graph of f of x equals negative tan x and the interval negative pi to pi, for what value of x does the graph meet the x-axis? So again, we're trying to meet the x-axis. We want to... Now they restrict us from negative pi to pi, but pi is not part of the domain. It's got a parenthesis here. So this side would not be a part of our domain or our interval that they give us for the graph. So we're gonna ignore this piece. Focus on negative pi being a bracket. That is part of it. So this is one of the zeros. We can drag this dot up. And then we could also drag this dot up. Now we're going to switch to some different objectives. So we've covered these two. Let's go ahead and go to maybe graph transformations. So we'll start here. So we're going to graph tangent or cotangent functions over different periods. Now, we're going to go ahead and use, I'm going to pull up this formula. So actually, I'm just going to type it into Desmos. So y equals a, and then this would be sine bx minus c plus d. This was our equation for graphing that we had in the previous section. This actually works for any trig function, whether it's cotangent, tangent, cosecant, secant, or cosine. A is our amplitude. B is going to help us find the period. We've got C here, which is our shift left and right, a horizontal shift, and we got D, which is our vertical shift up or down. So what we want to do is we want to identify those pieces. So we go back to this function, and we can see we have an amplitude of 4, and then we have a b value of 2. So for the tangent function has a period of pi. So there's this equation that we talked about the other day, which says that we can find the period by saying that that is equal to 2 pi over b. But that's really just true for cotangent, or not cotangent, that's true for sine, cosine, cosecant, and secant x. So those are the 4 functions where you use 2 pi over b. If you want to find the period of tangent and cotangent, we're going to say period is equal to pi over b, because its normal period is pi, so we're going to divide by this b part, which is really the horizontal stretch and compression for it. And this is for the cotangent function and the tangent function. So in our case, we had our period, which was going to be equal to pi over some b value. If we go back and look at what the b value would be, the b value for us was 2. So we're really looking at a period of pi over 2, because b is 2. So we have an amplitude of, so we have period is pi over 2, and we have an amp, which was 4, based on this graph here, or this equation here. So the first thing I want you to do is I want you to take care of the period first. So if the period is pi over 2, right now we're going from negative pi over 2 to pi over 2, which if you add the distance from 0 to here, and this distance from 0 to here, that would be a total of pi. We want to shrink that down to pi over 2. So if I go from negative pi over 4 to pi over 4, I have pi over 2 for my period now. My amplitude is supposed to be 4. Right now it's at 1. I want to extend that all the way up to 4. And then I've now graphed this equation correctly. Now we're going to graph transformations of tangent or cotangent functions again, but they give us a little bit extra information here. So we're going to go back to Desmos, and we're going to say that now our amplitude is 2 for that, because of our leading coefficient. We've got a 2 for the leading coefficient of x, so that's b. So we have still pi over 2 here, right? B would be 2, so we still have pi over 2 for the period. But we have some extra stuff here. So we have a vertical shift of 2. So we're going to say vertical shift of positive 2. And then what we need to figure out is we need to figure out the phase shift. To figure out the phase shift, you set the inside of this equal to 0. So we have 2x minus pi. We're going to set that equal to 0. So we're going to have 2x minus pi is equal to 0. We're going to add pi to the other side, so that'd be 2x is equal to pi. And then we're going to divide by 2, and that would be x is equal to pi over 2. So our phase shift, which I'm going to put right here, I'm just going to write phase, would be pi over 2. So we have the period, which is pi over 2, the amplitude, which is 2, the vertical shift, which is positive 2, and we have a phase shift of pi over 2. Now we're going to change the graph by doing the period first, then the amplitude, and then the vertical shift, and then the phase shift. So let's start with the period. Right now the period goes from negative pi over 2 to pi over 2, which is a total of pi. So I'm going to shrink that down to pi over 2, which would be negative pi over 4 to pi over 4. Now, if we look at that function again, our amplitude is 2. So this piece right here, we can move that now to an amplitude of 2. Now we're going to take care of the vertical shift plus 2. To do that, we're going to move this whole function up 2. And then we have to take care of the phase shift. So if I go back and look at what my phase shift was pi over 2. So I'm going to move this whole function to the right pi over 2. Pi over 2 would be right there. And then I'm going to hit submit, and I have now graphed that function. Okay, we're back to the objective of graph tangent or cotangent functions over different periods. They give us 4 for the amplitude, and they say that b is 4. So I can go back to this piece here and say that my b was 4. So this period now would be pi over 4. I'm going to delete all this algebra work I did earlier. So I have the period at pi over 4. My amplitude was 4 because of the leading coefficient on this equation. And I don't need to worry about the vertical or the phase shift. So I'm going to ignore those by just hitting X. So I just need to graph the period and the amplitude. So we're going to start with the period. It needs to be, period was pi over 4. So I need to have this at pi over 8 and negative pi over 8, because if I add those distances together, that'd be 2 pi over 8, which is pi over 4. So I move them in. Now I have a distance of pi over 4 there. My amplitude was 4, so I'm going to move this up from 1 to 4, and then I'm going to hit submit. We're going to do one more of these. They give us an amplitude of 1/2. So I'm going to write that in there. Amplitude is 1/2. If I go back to that function, I have, in fact, you know what? I'm just going to copy this, and we'll put it over here so we can look at it. I don't have to go back and forth. Whoop. That did not copy correctly. So it looks like we are going to have to go back and forth. All right, we got the amplitude is 1/2. We have a vertical shift of 1, so I need to add that in there. So we're going to say vertical shift of +1. We've got a b value of 3. So my period is not pi over 4, it's pi over 3. And then we need the phase shift. To find the phase shift, I'm going to set the inside piece right here equal to 0. So 3x plus 3 pi over 4. 3x plus 3 pi over 4. It's going to equal 0. Then I'm going to solve that. So I subtract 3 pi over 4 over. I'd have 3x is equal to negative 3 pi over 4. I'm going to divide by 3 now. And when I divide by 3, I get x is equal to negative 3 pi over 12. But that reduces to negative pi over 4. So my phase shift would be negative pi over 4. Let's copy that up. So start with graphing the period, then the amplitude, then the vertical shift, then the phase shift. So period first, which was pi over 3. Right now we're at pi. We need to drag that in until we get to pi over 3. Right there would be pi over 3. Pi over 2, then this is a little bit short of pi over 2. Pi over 3 would be. And then we want to go back and we want to do the amplitude, which is 1/2. So instead of the amplitude being 1, I drag that down to being 1/2. I've got a vertical shift, which I can see from the equation, which was +1. So let's move that up 1. And then we have our phase shift, which we can get from right here, -pi/4. So I'm going to drag this equation back to -pi/4. -pi/4 is right here. And now I have it at -pi/4. That should be the graph. Okay, let's switch this and go to graph transformation of secant and cosecant functions. I'm probably only going to get to do one of each. So we'll start with graph cosecant functions. Now the only difference between the cosecant and secant functions and the cotangent and tangent functions is now we're not going to do pi/b. We're actually going to do this. So instead of pi/b for cotangent and tangent, we're going to do 2pi/b. So I'm going to switch this to kind of clean this up a bit. I'm going to switch this now to 2pi over my b value. Okay, so I'm going to go back to the equation, which is cosecant of 1/2 x minus pi/4 minus 1. So I don't have an amplitude, it's just 1. Amplitude's 1, so I'm just going to put 1 there. My b value would be this 1/2 value. So if I put in 2pi divided by 1/2, that's actually equal to 4pi. I need to find the phase shift and the vertical shift. So vertical shift, if I go back to that function, vertical shift is -1. We're going to put -1 there. And then the phase shift, we get from setting the inside here, this inside piece, equal to 0. So I'm going to have 1/2 parenthesis x minus pi/4. So pi/4 is equal to 0. I distribute the 1/2, and I'll have 1/2 x minus, when I take 1/2 times pi/4, I get pi/8 equals 0. Then I'm going to add the pi/8 over, so 1/2 x is equal to pi/8. I'm going to multiply by 2, so I get x is equal to pi/4, because the 2 and the 8 will cancel. So my phase shift is pi/4. Now I'm going to graph these, starting with the period, which is 4pi, then the amplitude, then the vertical shift, then the phase shift. So we come down and make sure the period, and remember one period goes from the farthest left asymptote on, we're going to call this upper parabola, to the far right asymptote on a downward parabola. Basically I need the upward and the downward parabola both to happen for the cosecant function to go through one whole period. So it says my period is 4pi, so I need to extend this out till I get to 4pi. So right now I'm from 0 to 3pi. What I need to do is get from 0 to 4pi, so I'm going to drag this over a little bit so that I can get from 0 to 4pi. And I can see that if I'm on -pi and then the other side's on 3pi, I'm in the right spot. Now, one thing I got to remember is this vertical asymptote needs to be, like it should be starting on 0. So I'm actually going to drag that back once I've made the period 4pi. So I'm dragging it back to where it was to start. Now the amplitude's 1, and we're going to leave it as such. The vertical shift is -1. So we're going to drag this thing down to -1. And then the phase shift is pi/4. So we're going to move this over pi/4, which would be right here. And then we can go ahead and hit submit. All right, we got an error. Where did I mess up? Usually I mess up on the period when I do this. So, pi over 4 minus pi over 4, 0, cosecant of 0. Let's see, that's, oh, I'm on pi over 2 actually. This is pi. This would be pi over 2. I should be on pi over 4. I went over 1 too many, so I actually went over 1 too many on our phase shift. Let's go ahead and hit submit, and we're good. Okay, I'm not going to have time to do a secant function, but the secant function is going to act just like this cosecant function.